Hey guys, I'm going to do a quick run through, a quick help on the homework that some of you struggled on. I'm going to extend it once more time. These are also good problems to review for tomorrow's test. So here you go. So the thing that I think in class threw a few of us off, when I say maximize profit, you have to create the profit function. So that's revenue minus cost that I have up there. Remember, revenue is x times that price function, and then minus the cost function. So, and then the thing that's tricky is distributing the x and distributing the negative. So I'm going to make sure you do that carefully. So that's done. And then you combine like terms. This is not the derivative, remember. This is just combining those like things, just all the algebra stuff. So here is the nice cleaned up version. If you need to rewind and go see that again, that's fine. But I wanted to show you, maybe I'll back up just a tad bit, a little bit later. But the idea is that, remember, we just took combine like terms, get it all cleaned up. I put that in here as this function. And sorry, I erased all that. I just needed this space. So you might want to step back and see where that step came from. But now you take the derivative, and that's what p prime is indicating. Derivative the old-fashioned way, 2 times negative 0.5 is negative 1, x to the first. And the 71x minus 71x becomes minus 71. There's your derivative. When you're maximizing profit, you find where the first derivative is equal to 0. So I'm going to set this equal to 0. Little algebra to solve that. So, sorry, that's a positive 71 in there. Left that off before. So you subtract 71 or add x, whatever you want to do to solve for x, get x by itself. But I'm going to add x to both sides, and I get 71 equals x. So however you solve negative x plus 71 equals 0, you do it your route, but you get 71. You've seen my little guy. Thanks, buddy. Then you take that x equals 71. That's not your answer. I need to get the price that yields maximum profit. This is just the number of units that would be produced to produce maximum profit. So I use that x number of units in the price function, and that would make this 121 minus 0.5 times 71 instead of x, and that ends up being a grand total of $85.50 dollars per unit. Now, maximizing, when the profit is maximized, this part B, when I say when the profit is maximized, that's kind of calculus speak for at this x value you got for the location of the maximum, that x equals 71. So when the profit is maximized really means at x equals 71. What is the average cost per unit? So average cost is an easy calculation. It's just the cost function divided by x. So if I write it out, here's the cost function, the one we have in our original problem, divided by x. And of course, if I want an actual value, you put the x in, and our x is 71. That's the x that corresponds to this maximum profit. So putting in the x of 71, looks like this, and we get 50.46. That's for my example. So there you are. So that's my example 5. Then number 6. You ready for that piece? Yeah. Good job, honey. It's okay. Number 6 here. If you distribute that 2, this makes the derivative a lot easier. And it says find dy dt. That's implicit differentiation. So to get that, you take the derivative of each side with respect to t. And that means dy dt on the left, and then your regular derivative on the right, but don't forget the dx dt after each derivative. So notice those. Now we have values like x equals 4 and dx dt equals 3, so I'm going to put those in where they belong. And it looks like this. Multiply that out, subtract, and just do all your calculations. Calculators, very helpful in this regard. You should get 30, so that's dy dt. Dx dt is from the same derivative. The only thing is algebraically, so here's the same derivative that we took. I need to get dx dt by itself so that I can see what it is. I can put in the values that are given, x equals 1 and dy dt equals 6. I can put those in right now. But actually what I want to do is get dx dt by itself algebraically first. And the way that happens, you may not know this, is we haven't done it in a while, is you factor out the dx dt. They have in common in that derivative. So watch how this happens. So I'm going to factor out dx dt, and it leaves behind 4x minus 6. So now we have dy dt equals this factored out dx dt times 4x minus 6 from the factoring. Now I want dx dt by itself, so I need to divide both sides by that 4x plus 6 to get dx dt by itself. So here's the division by 4x plus 6. So there it is, divide both sides by 4x plus, or minus 6, sorry. That's important because now I can cancel the 4x minus 6's on the right. That's what I wanted to do. And here's what I have. dy dt over 4x minus 6 equals dx over dt. I switched the equation around. I flipped it around, but I just wanted to have dx dt on the left. Now you can put in the values. X equals 1, dy dt equals 6, and it looks like this. That'll give us a value. A little calculator should get you -3, and that's the end of number 6. So that's just those two. Email with questions. I'm going to send you another video soon about the other two.